Okay, welcome back real quick. So actually, I forgot that there was actually one question that was asked after one of the recitations sessions. There actually was a question that some of you tried to solve. I think it may have been a previous question. It's an actual previous question this time, and it was something along these lines. If you have some string, some binary string that starts and ends with a 0, it will have the same number of 1, 0 and 0, 1 substrings. I don't remember exactly the wording of it, but it was something along these lines that you have to prove this. So for example, say we had, so again, it's some binary string, so it's only made up of ones and zeros. It should start and end with 0, and no matter what format of strings you have in the middle, it's always going to have the same number of 1, 0 and 0, 1 substrings. So let's see this one. For example, how many 0, 1s does it have? So let's see, 1, 2, 3. So we have 3 0, 1s, and how many 1 zeros? So here, 1, 2, and 3. So also 3 1 zeros. So it's an interesting fact, right? Like if you have a binary string, no matter, and it starts and ends with 0, no matter how it goes, it's going to have the same number of 0, 1 and 1, 0 substrings. Now, I'm not sure if this is the best way to do it, but so in class we thought a few things, and we ended up deciding on induction. And somebody asked, hey, why did we choose induction? Well, through my head, what would go on? Think of CMPS 211, right? Like how many different ways of proofs are there? Like how can I prove this? Well, there's direct proof, contradiction, like maybe assume the opposite and reach a contradiction. There's, we said induction. And so like maybe we could use contrapositive. There's lots of proof ideas. Direct proof, I didn't see like a way to do that. Like direct proof means, hey, right away, can you prove this given maybe some assumption? Not sure if we could do that. Contradiction, I didn't try it. I thought of induction and it made sense. So induction in the sense that we will prove that any string of any length will have this property. So the way that we do that, first so let's try using induction. So first we'll prove it for some n, right? So for some cases, step 1, let's try for n is 2, right? Since it has to start and end with 0, its length has to be at least 2. So for n is 2, we have the string 0, 0. It has the same number of 1, 0 and 0, 1 substrings. It just happens to be 0. Then we'll try a few more. So let's say for n is 3. We have two strings in this case. We have the string 0, 1, 0, or 0, 0, 0, first of all, same thing as here. So it's true here. And we have the string 0, 1, 0, true here as well. You could try some maybe n equals 4, n equals 5 if you want some more examples. We usually with the base case, step 1, proving it for some base case, it's enough to do 1. But I usually like to do 2 or 3 to get an idea of what I have. Okay, so now step 2. which says if I can make this go backwards. You know what? Let's do it here. So step 2, assume it's true. If you remember, it's either up to some n equals k or for n equal k. I'll say for n equals k because I don't think we'll need more than that. If you do this, then later when you're doing step 3, you feel you might need more, you can simply go back here and say it's true up to n equals k. It's just like changing the English words. Step 3, let's prove it for n equals k plus 1. Okay, to do that, we'll start with some string w. So assume you have some string w. So using step 2, I have w such that the size of w is k and the number of zeros, 0 ones and 1 zeros is the same. So here we'll say the number of 1 zeros should equal the 0 ones. Okay. This is what we have as given. Now we want to try to prove it for k plus 1. Well, you have string w, right? String w is of some length k. It can be anything as long as it starts with 0 and ends with 0, and it has this property. What will happen when you put some random number inside w? That number, of course, has to be either 1 or 0. Now we will try to insert in the middle or somewhere in the middle, doesn't have to be exactly in the middle, of w either a 1 or 0 to get a new string w prime such that the length of w prime is k plus 1. Now we have to prove that this is also true for w prime, right? So we started with step 2. We have w, its length is k, it has the property. And of course, w starts and ends with 0. Now in this w, somewhere randomly in the middle, you'll insert either a 1 or a 0, and you're going to get a new string. The length is k plus 1, which is what we're trying to prove. We just now have to prove this property, so let's do that. So w prime, or first of all, we started with w, and we are inserted somewhere, either a 1 or a 0. Let's do first 1. Let's do 1 and see what happens. If you insert 1, I want to try and focus on this area where you're actually inserting it, because that's what matters. So we inserted 1. What's going to be on the left and right of this 1 that you inserted? Like what's going to be here and here? Go through all the cases. It's either going to be 0, 0 or 0, 1. Say 1, 1. Let's do that first. So all 1s or 0, 1, 1 or 1, 1, 0. These are all the cases where in the middle you have 1 that you inserted and what can be on its left and right. So let's see all the cases. The first 2 are pretty straightforward. Yes, in this scenario, what's going to happen? Okay. Oof. Okay. So here, Before it was 0, 0. We inserted not like you 0, 0 somewhere, right? And we inserted 1 in the middle, and we inserted 1 right here. 1, it became this much. So the number of one zero substrings, what's that number going to be? It's gonna equal how many 1 zeros we had in W plus 1. Yes or no? What do you think of what I wrote here? Whoops. What do you think? Plus 1. First of all, if you ignore the 1 for a second, before, like, we added a 1, right? So obviously it's going to have the same number of substrings plus something that we added. This is what I'm trying to say. W prime has the same 1 zeros as W because it was that string. We just inserted something in the middle. And that thing that we inserted was right here. Like we added a 1 0. So we got a new substring because before it was 0 0. So in this part there was nothing extra, but here we got something extra. And for the 0 ones, it's the same thing. For 0, 1. Also, we got 1 extra. And since we already mentioned that this equals this, then for this case, it's true. Okay. Repeat it one more time. This was the string W. When I insert 1 or 0, inserting 1 or 0 will get me W prime, which I'm trying to, so the length of W prime is k plus 1. Now I'm just trying to prove that it also has the property where the number of this part equals this part. So I'm going through all the cases. What if what I insert was 1? Okay, so somewhere random in the middle, I inserted 1 here, and I got this. So literally, there's a new 1 0 substring and a new 0 1 substring. So W prime, the number of 1 zeros substrings, is whatever the number in W was with an addition of 1. Same thing for the 0 1 with an addition of 1, but since these are the same, then the whole thing is the same. Okay. For this part, same thing. Like you added 1 in the middle instead. But the 1 1 you had to your left and right, that means no extra substrings. Okay, let's go through the cases. For 1 1 1, nothing, no extra substrings. Of 1 0, and 0, 1. So they're still the same. And since they're equal to whatever W was, they're all the same. Now this one is actually interesting. What about 0, 1, 1? Did anything change here? So before, what was it? Before it was, and I inserted 1 and it became, think about it. Did anything change in this case? Like you had it, you had this was 0, this 0, 1 counted to some substring. Now instead of it being this one, it's this one instead. So no change in the number of substrings since like some 0, 1 was replaced by another 0, 1, right? Like instead of it being this one, now it's being this one. Like imagine you subtracted 1, but you added 1 as well. And finally, for similar reasons, 1, 1, 0 is the same thing. So what was it before? Before it was 1, 0, you added 1 in the middle, so it became 1, 1, 0. Okay. And here, 1, 0. We can then finally say, similarly, if we had inserted 0 in the middle instead of 1, we would have gotten a similar explanation to here. So this is actually a really nice question. Now, I said a lot of details. I don't know if you have to be this specific, but try your best. Like, how did we start with this? Okay, we said induction. This part should, like, try to get it as close to a formal proof as you can. Like, this is, I think everybody should be able, if you thought of induction, you should be able to do this part. Step 1, like it's doing some cases. Step 2 is the assumption. Step 3 in the proof, here you might vary in the in how specific you be. Like I'm like with this formal, are you able to do this? If you're able to, great. But again, as much as you can, try to get it close to this. So what did we do? One last go through it. We're trying to prove it for n equals k plus 1. We started with our assumption. Hey, we're able to create W of length k, and it has the property. Can I now say I can do it for k plus 1? So we're trying to prove it's true for any string of any length. So we assumed it for k, we're trying to prove it for the next one. And we're going to create the next one using the assumption. So this is W. And we will insert somewhere random in the middle of W, either a 1 or a 0, that's what we did. And we get W prime is of the proper length. Now we just have to prove that the property is proper as well, or is satisfied as well. So W was starting with 0, ending with 0. We randomly chose something in the middle. It's not exactly in the middle, anywhere between. Like we could have actually chosen this part. Like you could have chosen to insert the 1 right here or the 0 right here. Nothing's stopping you. But of course, you can't insert a 1 here because now it's no longer ending and starting with 0. Okay, so we decided to focus on entering the 1. I entered 1 somewhere in the middle. I'll get 4 cases. 0, 1, 0, 1, 1, 1, etc. For the first one, when you insert 1 between the two zeros, you'll get an extra substring of each. For the 1, 1, 1, you won't get anything extra, so it's still as before. For 0, 1, 1, and 1, 1, 0, as you saw, it's still no extra, but it's just the difference is which numbers count to it. Before it was 0, 1, Now this old one doesn't count anymore. It's this new one with the old 0. Similarly, if we had inserted, so using induction, we were able to prove that any binary string, any length, or let's say, so a binary string, any length that starts and ends with 0 has the same 0, 1, and 1, 0 substrings. Has the same number of 0, 1, and 1, 0 substrings. Okay, so that's a really cool question. The more specific you be, of course, the closer you are to the correct answer. Okay, now, seriously, see you in the next one.